The two things that you need to worry about while building an AI application are its speed and accuracy. When you build an AI application, you want to make sure that it predicts the right things as well as it is fast. But most of the tutorials online gives you the normal way of creating an AI application, which usually works, but it is slow as well as you feel that your detections are laggy. You can see that this application works really fast. And we are using the right TensorRT way, which is quite fast. And we are not only giving you the script, most of the people runs away with giving you just the script, but we are going to show you how to build this application from the neural network, the model, to the interface, the screen. So by end of this video, you will be catered to build a real AI application using YOLO 11 or any versions of YOLO within your system, and you don't have to use any cloud compute to implement or deploy this application. So let's build it. An AI application is not all about the AI model that you build. Of course, the AI model is really smart, but it cannot interact with the users until it has two more things that we discuss here in the video. First one is the user interface. User interface can be the screen or the face of your application. This is where the users or you can interact with the AI application that you build. So here there are buttons and upload images where you can use these buttons or the available interface and interact with the application that is provided for you. And this is how you interact with the AI model that is available in the backend. And how do you connect this front or the screen to the AI model in the back? There is a bridge that connects this particular these two aspects of the AI application called FastAPI. So here we are going to use a tool called FastAPI from Python to make sure that these two aspects of the AI models are connected, and that is the most important part that we need to learn. And today we are not only going to discuss about the AI model, but also these two parts, the front end, the fast-end API, the bridge, as well as the AI model in the backend. So you can start building this application by installing the tools that are available in the requirements.txt. So basically there are like really very few tools that you need to use. First one is the fast API. You have to install this so that you can bridge the front end with the backend or with the model. Then you have Uvicorn. Uvicorn, you can think Uvicorn is like an engine that keeps the fast API keep up and running. So without the Uvicorn, the fast API will be closed and you won't be able to use the application as such. Then you have to install Ultralytics. So Ultralytics is the library or the most popular library where most of the YOLO versions are available. So once you install these particular libraries, you can check out the folder. In there you can see that I have written the app.py where the most of the logic or the application logic behind this particular application is written, and you have the index.html file where the screen or the UI of this application is written and listed. So I have kept this file separate so that this application looks clean and easy to understand. So you can just explore this repository that I have put it in the comments or description below, and you can easily identify and install the requirements as well as check out the folder structure. After setting up the folder structure as well as installing the requirements, let's move on to the next step required to build this AI model called cleaning the data. So usually an AI model sees the images as dots of pixels. So when you send a large amount of information to the AI model, it becomes usually slow as well as laggy. That is where we need to resize and crop the images into the perfect size so the AI model can run efficiently on those particular data. Not only that, since the images as seen by the model are dots of pixels, you need to make sure that these dot of pixel or data needs to be in the particular range that is understandable by the AI model. That is why we normalize these images into the range of 0 to 1 so that the images values or the pixel values do not vary between a large value. And these are easily handled by the Ultralytics library, but deep down you need to understand why and how this is being done manually. Now let's check out the bridge or the app.py file in this particular repository. So basically, this is where the whole logic or where the whole application is being controlled. So inside the app.py, you can see a path called /info. So that is the gate that keeps this application up and running. So when you upload a particular image through your screen or the front end, that image is being sent to this particular gate. And from there, you can see that you are using an YOLO model or initializing the YOLO model, and you are taking these images and sending the image to the YOLO model. So inside the Ultralytics library, the images are being processed or pre-processed using that resizing as well as normalizing. So once that is being done, it is sent to the YOLO model and the outputs are returned, and these outputs are usually messy and in the form of tensors, and you don't want to show those tensors to the users, but you want to show the outputs. That is where another helper function called post-processing comes in. So basically what post-processing usually does is that YOLO model usually predicts multiple objects for a single object. So you might use NMS, or you might suppose those predictions and predict the actual results that is required by the user. So after that post-processing, these particular bounding boxes are sent back, and that are being sent back to the user as bounding box or rectangle boxes that is available in the UI. The index.html file gives you the UI that you can visualize, from where you can visualize the output of the YOLO model or our AI application. So basically inside the index.html file, we have the JavaScript as well as, of course, with HTML file, we have some JavaScript code that interacts with the bridge or the /info gate that is available in the FastAPI. So once you upload the images, this JavaScript script talks to the Python file or Python and sends the images to the Python file. So, and even after the inference, you get multiple endpoints or multiple bounding box description from the Python file, and these Python endpoints or multiple BB box information is sent back to the index.html file, and that is being drawn onto the screen using the JavaScript file. So basically, you don't have to use the terminal and understand what is happening in the backend or what is happening, what is being identified by the AI model, but you have this being done by the JavaScript code automatically, and you will get the output in the, and you can visualize the output in the screen. Now let's move on to the most highlighted part of this video, introducing the TensorRT Way. So usually when most of the AI models are stored in PyTorch, and most of these AI models will be running on the CPU in the backend, and these are extremely slow. So that's where this TensorRT comes into the picture. And in the TensorRT model is so optimized that even in the GPU, the TensorRT models will be highly faster than the PyTorch version of that particular model. So here you can use the TensorRT engine to convert the PyTorch model. First you have to convert the PyTorch model into the ONNs and use the TensorRT engine to convert that ONNs model into TensorRT, so that the CUDA GPU can, or the NVIDIA GPU can efficiently compile the model and run it much faster than the PyTorch model that is usually available in the repositories. So on top of the smart app.py file that you have written that contributes to the bridge of this AI application, you can make this brain much faster by using the TensorRT engine to convert the AI model and to run the application much faster. So nowadays, building an AI application with the tools that you have available, building an AI application is not much of a hurdle. You can build AI application even in a single day, but you just need to know the concepts behind how these AI applications are working up and making it up and running. So I suggest that the most of the codes that I have used for this particular video that I have said in this video is available in this repository in the description below. So I will suggest you to clone this repository, make it run, share it with your friends, and explore it much further, so that you can also explore other parts of a TensorRT, like quantizing the model, make it much faster, pruning the model, etc. And if you like technical stuff and you like to interact with technology and tinker with it, I would really suggest you to subscribe to this channel as well as to like this video. So bye.